So the idea is that the technology that we are experiencing, from the smartphone to the cloud, can really enhance the way we live and try to address issues that we will see together. And smart cities is quite a broad concept, so I try to use this definition that is from the UK government. The idea is that it's a place, a smart cities, where everyone living in the city, from the citizen, the public institution, that can cooperate. In fact, sometimes we call them collaborative cities. And the idea is to improve and make an attractive environment for everybody living in the town. So one big technology step that can power the development of smart cities is the Internet of Things. The Internet of Things is one of those buzzwords that has been around for probably decades. I think we're getting into something concrete because we are starting to see real deployments now. And the business around the Internet of Things is exploding. According to major analysts such as Gartner or McKinsey, we are going to have 26 billion connected devices in a few years. And the value of the market surrounding the Internet of Things is going to be $11 trillion by 2025. So this is probably the technology that is powering this evolution of the cities. And we can start addressing those that are the classical concerns of citizens. For example, parking. Who has never had an issue with parking in the city where they live? So you live in a very nice area, probably. So this is an example done in Santander in the north of Spain. So they use sensors, and from the picture you can start to see that it's a standard hardware device that you can really buy and assemble online that is put in the pavement of the parking slots. And then they use bridge, because these sensors, usually they are very low power, so you can't expect them to transmit information far away. So they use a bridge network that is based on a Wi-Fi relay that is amplifying the distance of those sensors and sending back the information on the parking slots, so that you can easily see on the map where there is an available parking slot. You can go there and use it. But still, we are using here a physical device for every parking slot, so it's not really scalable for a city with millions of users. This is Chicago. This is Chicago. This is Chicago, and they use the physical infrastructure of the public transport, like the bus stops, to put sensors to measure air quality, noise, all those environmental variables that can impact the life of citizens. And this is slightly a step further, because they're starting to use a physical infrastructure that is already there, the bus stops, to make them smarter and collect information that can be used to improve the life of the people. Sometimes there is a slight delay in the change. Oops. So one hot topic is air quality. And this is an example not far from here. This is in Serbia, in the town of Belgrade and Pančevo. So they wanted to collect information about air quality, but they didn't want to scale these sensors across all the town. So they used something that is already moving across all the town. That is the bus, the public transportation. So you put sensors on top of the bus, and you get a lot of information, not only on the public transportation itself, but also on the air quality or possibly noise, everything that is surrounding the moving target of those sensors. So this is starting to be more scalable, because we don't need to deploy sensors across all the town. We use a public infrastructure that is moving itself. So what we see, in fact, is that sensor itself, even if they are getting cheaper and cheaper, they are still expensive, especially to manage at scale. Maybe a sensor itself, you can build it with a few dollars, but the fact that you have to place it, maintain it, keep it updated, securely connected, is not that easy. Mobile devices, on the other side, is something that we are very comfortable with. We always have them in our pockets. We use them daily. Sometimes we do. I was on a conference last week, and people asked, how many people didn't look at their smartphone in the last 4 hours? And nobody raised their hands. So it's really become an intimate part of our lives, strangely enough. And the idea here is to see how we can use these two technologies together. So the idea is to use IoT and mobile devices together to expand the capability and the scaling of this IoT infrastructure, so that they become cheaper to implement, but still we get the advantage of having them. So this is an example. So if we want to understand how people is flowing in a city, we can just use passive trackers that look for Wi-Fi or Bluetooth devices. And you can know how the devices of the people, you can use any smartphone, is flowing around your town. So you know where a lot of population is and is not. So in case of emergencies, or you know where the citizens are based. And this is something that is already done, because when you enable Wi-Fi in your smartphone, Wi-Fi is used to find your location, because it has already been joined with the GPS location of the Wi-Fi receiver. So this is very cheap to implement, because physically you don't need to change anything, and you start to get some information. But you can also get more information from this approach. This is a similar approach, but on a street. So if you want to understand how the traffic is flowing, you can use these sensors to track so the standard Wi-Fi or Bluetooth network to track the devices. And you can also track speed in this way, because you can see if the same device is connected to one endpoint at one point, and then is connected to another one at time one, then you know the distance between these two devices, and it's high school physics to see the speed of the flow of the traffic. So you can understand where traffic jams are and where not, without deploying a new physical sensors on the street. And there are other solutions that spoil this infrastructure that is already in place. This is Park Smart. It's a startup. They created a solution to find spark spots, but they don't need sensors like in the Santander example. They use the normal surveillance camera that are already in place in a lot of public and private places. So if you already have a camera that is overlooking at parking spots, they have the smartness in their application to understand where the spots are, if they are used by a car or not, and then they can drive you to the closest parking spot. They support both public customers, like towns, or even private parkings, like for shopping malls. And the other point is, OK, now we've seen how to collect data, but this is not the only issue, because sometimes the problem with towns and cities is not that they don't have data. Towns, they have huge quantity of data historically. The problem is using the data. That's why open data sets are important, because a lot of the data that towns have is public data. Today we discussed a lot about privacy, but in the public space, there's a lot of data that is public by definition. So why don't we use the cloud to share it so that maybe someone can use it in a more effective way? And the idea is really to create collaborative cities where the citizens are not passively living the city, but are the backbone of the nervous system of the town. So we have 3 points. So this is probably the way the best definition of a collaborative smart city. So you have, on one side, the data that you can get from sensors, so the physical sensors that you deploy. On the other extreme, you have data that you get from the town, the open data. You have data that you get from the citizens, if they are willing to share. And all this information can be analyzed and used to improve the experience of the people. So you can use it for visualizing the data with a classical data warehouse, business intelligence tool. But you can also build predictive technologies on this data to understand where traffic is going. In the short term, so tomorrow there will be traffic in this place, or in the long term, where it's even more important. So if we continue in this way, in 1 year, this road will be impossible to travel in the morning. And regarding citizens, the idea is really that if they are willing to share, there is lots of information. So we saw how they can use citizen devices to understand where they are located, how they are moving, if there's traffic or not. There's a lot of information that people share publicly on the social media. And this is very important to understand the mood of the citizens. And there's a lot of open data that is shared by large and small organizations, like image of the landscape at medium or high resolution, or the weather forecast. That's another important information. If you know the traffic and you know the weather forecast for tomorrow or the next week, you can already start planning to improve the experience of the people. And this is a very basic example of how open data can be used to improve the life of citizens. So the town of Chicago, as a lot of other towns, they have a weekly plan a bi-weekly plan to clean streets. And if you park the car during the day where they clean the street, of course, you get a fine and your car is removed. So you have to remember and know where they are passing. And this can be a problem if you live in the neighborhood, and can also be a problem if you're just passing by the town. And all this information was in an Excel file in some public office, and it's public information. So they gave this Excel file as open data, and developers, they immediately created a framework to translate this Excel file in an open format like CSV, publish this information on a map, and create a framework to receive email alerts and add the recurring cleaning of the street to your calendar so that you receive the alert instead of being you to look for the information. This is very basic. It's something that a developer can create in less than a hackathon, in probably a couple of hours, but it was improving the experience of the citizens of Chicago. This is Boston. Street bumps are always an issue because you have to keep them maintained, and a lot of times the single citizen experience the bump, but for a town, knowing where is the priority to intervene is not that easy. But we all bring our mobile phone in our pocket or in our purse. So the idea is you know the location from the GPS of the phone. And if you have an app, this app can also use the accelerometer to find the bumps where you are driving or where you are using public transportation, such as bus, and send this information back to the town so that the town can collect and understand where street bumps can be an issue, and we must intervene as quickly as possible. Again, you don't need sensors. This is an example, a very serious example using social media. So the Black Dog Institute is a no-profit research institute in Australia, and they look into the best way to diagnose and solve mood issues such as depression. So they're using the social media to understand how the mood in the different town is changing, is improving, or going in the wrong direction over time. And all this information is also split into categories, male, female. So it really can help a town understand where their own population is steering and change the direction if they understand that they're going in the wrong one. Going back to sensor data, we have a platform as AWS that has been really designed to connect devices in a secure and private way. So this is a platform that offers a lot of features. I'm not entering into technical details now, but the idea is that being a cloud, you only pay on demand. So you have a free tier you can experience, and you don't pay anything. And then if you start using it, you pay $5 for every million of messages that are exchanged between the devices and the cloud. So usually that means that you can go far beyond the prototype stage without almost having no expenses, and then you can scale. And the idea is to safely connect the device in a secure way, so using mutual encryption, multiple protocols, and also solve two of the main issues of an IoT connected architecture. One is the quantity of data. So you have a large quantity of data. You don't want to process everything because it can be expensive. So we have a real engine that filter with a sort of SQL-like interface for the technical people what you want to grab and where you want to send this data. So if you have even millions and millions of information, you can extract the sub-information that you need and process only that data. And the second one is connectivity. When you have an IoT distributed network, you can't guarantee the connectivity of the devices. You can lose connectivity and get connectivity back. This is something that can make building an IoT application complex. We introduced the concept of device shadows. That means that your application is not talking with the physical device. It's talking with a shadow, a virtual device in the cloud that has the most updated information and that synchronizes automatically with the physical device. So if you lose connectivity, your application doesn't care, can still talk and change state. As soon as the device is back, it will be synchronized, giving back information or receiving commands to execute. So this is simplifying a lot the experience of the developers. And examples that are using AWS are always interesting. This is Philips, their City Touch project. It's in production in Prague and in a place close to London. So the idea is to bring the smartness of the city lighting to the next level. So they're not just using light sensors to optimize the light. So of course, you don't use a timer, but you really look at the actual lighting of the place to decide how much light you need to generate so you can optimize cost. but they want to create something smarter. So for example, if you have an emergency vehicle, such as an ambulance or a police car, driving through a road, they can increase, following the car, the lightning, so that people that is in the road can experience the great light, so it's safer for the people, and it's safer for the device, for the vehicle to go through the town. And this is an interesting slide. So can you imagine what is in this slide? So this is a specific phase of a data warehouse process. And it's an ETL, an extract and transformation phase. This is 1939. In 1939, the London Underground, they wanted to understand how people was using the underground, to understand where they needed to create more lines, where the lines were used the most or the less. So the only way at the time was to have human people looking at 4 million of tickets for a period of time, writing down all the numbers to process this information. Why I'm showing you that? Because at the time, it was already useful to do this kind of heroic efforts, I would say. Now it's so easy to process digital data, to enhance the experience, to plan better infrastructure for the town. So really, we don't have excuse to not use these technologies to improve the life of the citizens. And I will go fast on the low-level technology because I want to talk about other projects. This is the city of New York. The new measure, when he was in charge, he wanted to reduce the casualties and of the people in the streets. So one of the programs is the Vision Zero. The target of this project is really to have no casualty, no people dying for a transportation issue in New York. And what they did is they started to collect information, understands where the problems are, notify the people in the local neighborhood so that you know which street that is close to your house, which crossing is dangerous. And also using this information together with other tools to understand where to plan, where to change crossings, where to change the direction of the way of the streets, and really improve the infrastructure to reduce, if not eliminate, the casualties in the streets of New York. So putting it all together, as I said, we don't need to count the tickets anymore. We can collect information from sensors and smart devices, from citizens, things that people is sharing on the social media through their mobile devices, and from public data sets. There's a lot of public information, and the Chicago example shows you how an Excel life can, if shared, can improve the life of a lot of people. And then you can collect and process this data in batch, in real time, if you want. There's a lot of tools. And then you can share this data with other people that can take informed decisions. It can also be used for building citizen apps. We now start to be used to have information on public transportation, but knowing what is happening in your town in real time can really help. And can also be analyzed with traditional tools like business intelligence or predictive technologies such as machine learning. We have a catalog of solutions that customers build for improving the smart cities. So it's online. Those are a few categories that we have. If you click on those categories, you can find examples similar to the one that I shared today, but much more, of how to improve voting experience, job creation, healthcare in different towns across the world. And we also have a challenge that we run yearly. It's currently open. It's City on a Cloud, so any public administration or technology provider that has an idea to improve the life of citizens can participate to this challenge and will also be added to our portal. So it's absolutely open for submission. Thank you.